Good day everybody, my name is Christopher Conway. Welcome back to my channel, and today we're going to be doing something on chemistry. In this video, we're going to explore relative atomic mass and how we can do the calculations in Python. This is used in calculating isotopes. The number of electrons, the percentage of the number of electrons plus the other percentage of electrons will equal over 100 will give you a certain result. And today we're going to explore that in Python. I've found a way to do that. And that's something that no one has ever done or figured out before in Python, but I'll just show you how it's done. So here it is, the number of isotopes. And the input must be in an integer form. That means it must be only a number. And this is even in a percentage. If you like, you can also put it in float. So if number of isotopes equals to 1, the mass number of isotopes integer input, what's the mass of the isotope? Then what's the percentage of the mass number of the isotope? So it's basically with relative atomic mass is percentage of the mass number of isotopes times the mass number of isotopes over 100. And that should probably give you your relative atomic mass. Same thing applies for the second. So what's the mass of the first isotope, the percentage of the first isotope, then the mass number of the second isotope, and what's the percentage of the mass number of the second isotope, then percentage of mass number of isotope times mass number of isotope, and you have it again, except it's 2 divided by 100. Then it will give you the relative atomic mass of the element to be this. So technically, all of these are the same thing as the first two, except they've expanded themselves to 2, 3, 4. Then the maximum amount of isotopes you can do for relative atomic mass. So the highest number of isotopes you can have in an element is 10. But according to my research, I've done something like 4 to 6. But for the sake of this video, I decided to do just 10. Simple. So without further ado, let's move on to the quiz. Here we are at the quiz. So after, I'll run the program and let's see how it is done. I'm changing formats every day of how we do things. Alright, so let's begin the quiz. Next. Isotopes are defined as atoms with the same number of protons but different numbers of neutrons. And it's majorly only one. What could it be? It's the if statement, people. You should guess this one from the previous video. Same thing for here too. So as shown according to the one in the program. So this might come out in the quiz, which I already did. What about 1? What about 5? You already know the answer to this. 3, 2, 1, and the answer is that. Next one. The answer is 10. So I've completed the quiz. Without further delays, let's just run the program. So I have let's say we have 38 isotopes. It only asks us for the number. So the mass number is 38. Oh, I know why it didn't work like that. Because if it's above 10, it will definitely give you an error. It will definitely not answer. The percentage of this is 45. Just enter in random things until the end. Whoops, that's what happens when you do things like that. Sorry if this is taking any of the time. Almost there to the result. Now we have 84. So here we have it. The relative mass of our elements is 20,334.4. Though it's not normal, but it still gives a bell to a ringer. So you might even use this whenever you need it. But don't use it to cheat, even though this is just a test run. So that's it for the video. Hello guys, this is Christopher Clowney. So I hope you've enjoyed my video today, and hope I see you in the next video, which I'm going to be doing something special. Goodbye folks, and have a good and wonderful day.